Okay, this is Mrs. Kirkman again, and I'm going to try to work some problems with y'all and help you understand multiple ratios a little bit better. So we were talking about the ratios in a balanced equation, and so we were using this one, and this is a 1 to 3 to 2 ratio based off of those numbers in front, 1 to 3 to 2. Remember, if it's a 1, it doesn't have anything in front. And so I talked about if I double those, I have to double all of them. If I half them, I would also have to half all of them. And I gave you some examples in the previous video. If you haven't watched that, you should go back and watch it. Now we're going to work a problem with actual numbers, because in chemistry, in life, do we ever use whole numbers? I mean, like, very rarely. You go to the store and something doesn't cost $5, it costs $4.99, and then you have tax. Or it's $4.20 something or whatever. But never do you go to the grocery store or you go to the convenience store or the gas station and it's right at a perfect number. When I go fill up my car, I never fill it up and it's exactly 12 gallons. It's going to be, 11.75 or whatever I used for that day or that week. But numbers are very rarely in real life pretty beautiful whole numbers. And so we need to know how to work real chemistry problems. And so those numbers are not pretty, but the concept is still the same. That 1 to 3 to 2 ratio is going to stay the same. So all we have to do is look at that 1 to 3 to 2 ratio and make sure that we understand it. So here I have a problem for you. If you have, so I have 0.23 moles of nitrogen. So that's how much I have of this. That is much less than 1. Okay? How many moles of ammonia, NH3, will be produced? So I'm looking at this. I know that this is a 1 and this is a 2. So I have a 1 to 2 ratio. So that means that I'm going to double this, but I'm going to show you all the actual work for it. Okay? So the way I work these problems every single time is we're going to do the same steps. The same steps make it so much easier. So I'm going to be working it on the blank one, but I will hold up the question to remind us of it very often. So we're always going to identify our given and what we're looking for. I represent a given by G and what we're looking for by a question mark. So when I go back and read this problem, the information that I'm given, the information that I know is this right here. This is my given. I have 0.23 moles of nitrogen. It's important to know the compound because that's where we're going to start. So 0.23 moles of nitrogen is different than if I had 0.23 moles of hydrogen or ammonia. So this is my given. Then I'm going to finish and look and see what it's asking me for. How many moles of, so I want to know moles of ammonia. That's what I'm looking for. So I'm going to say what I'm looking for is moles of ammonia right there, like that. And so as I'm doing this, I'm going to plug in. So how I work this problem is I always start with my given. Every single time we're going to start with the information we're given because that's the only place to start. Whenever you're watching a murder mystery or a mystery of any type, the people can only start with what they're given, any clues that they're given, any evidence that they're given. They have to start somewhere and they start where the information leads. So this information right here is telling us to start with the only thing that we know. So I'm going to set it up kind of funny, but it's going to make units cancel. And I have other videos that you should watch about units canceling, and it'll help you explain this setup. It's called dimensional analysis. My phone fell. Okay, well, that might make this video funny, but I'm not going to start over. Okay, so right here, starting with my given. I like to make it fractions because we're going to multiply and divide, and so we can brush up on fraction math. But this is the same thing. I put it over 1. If I divide something by 1, it's the same thing. So I'll hold that up a little longer so you can see. So now then, I want to switch from moles of nitrogen to moles of ammonia. And I know for every 1 mole of nitrogen that is 2 moles of ammonia. I know this because that's my ratio that we talked about already. That's that ratio from the other part, the other slide. So this right here, Remember, this guy's a 1 and this guy's a 2, and so we're looking at this 1 to 2 ratio. We don't need hydrogen. The problem didn't ask us about hydrogen. So right here, I have over here this ratio. Now, I want to make units cancel. To get units to cancel, you need to divide it by itself. So I want to divide this by moles of nitrogen. So that means it needs to go on bottom because that means I'm dividing by it. So I'm going to take that ratio right there, that 1 to 2 ratio, and I'm going to put my moles of ammonia on top. I'm going to put my moles of nitrogen on bottom. Okay, when I do this, moles down here, see how it's the same units? So those are going to cancel out. They're going to cancel out, which leaves me with moles of ammonia, which is what I'm looking for. So all I have to do is take 0.23 and multiply it by 2. Okay, so then that answer would be 0.46. Now then, I'm going to quickly show you that that works the same way with our ratios that we were doing. So I'll hold this up one more time so we can kind of see the work, and then I'm going to erase it. And I'm going to show you how that fits with the previous video, what we were saying. So, we are talking about nitrogen and ammonia. So nitrogen is a 1. For every one of these guys, I need 2 of these guys, right? Okay, if I were to half this and make it 0.5, I would need to half this guy, right? Make it just 1. We divided by 2 both times. Well, guess what? If this guy's 0.23, there's no easy division. But look, this is just times 2. 0.5 times 2 is 1. So 0.23 times 2 is 0.46. It fits the same pattern. It's the same ratio that we just talked about. And guess what? That was the same work. I want you to set up your work the way I was showing you, though, with the like crossing out and you're making fractions, because it's going to make it to where when we get to longer problems and harder problems, it's going to make your life so much easier. And I explain that in my other videos, okay? Good luck, y'all.